Today we are going to discuss the concept of real and apparent flux densities. Consider a rotating machine. In this machine, the state of flux passes through the air gap and enters the rotor or enters the armature. Here the armature has slots and teeth arrangement. So the major part of the flux entering the armature from air gap passes through the teeth. So as we can see, the flux density in teeth is more as compared to slot. That means the slot carries less flux since the teeth is the minimum reluctance path for flux. If the machine is having a lower flux density, then the flux passing through slots can be neglected. That means the flux passing through the slot will be very much less as compared to that of teeth. But is having a higher flux density, then the teeth gets saturated and the remaining part of the flux has to choose another path through slot. So the flux passing through the slot will be high as compared to that of a machine with lesser flux density. So we can say the real flux passing through teeth, the real flux passing through teeth is always less than the total flux through the slot pitch. The real flux passing through teeth will be less than the total flux through the slot pitch because the remaining part of the flux will be passing through slot. So similarly we can say the real flux density in teeth is always less than the apparent flux density, that is the total flux density. Now let's define these terms, real flux density and apparent flux density. The apparent flux density or the total flux density is defined as the total flux in the slot pitch, that is the total flux entering the slot pitch. Slot pitch is the sum of width of slot and width of teeth, or this portion of the armature is known as the slot pitch, YS. So the flux in the slot pitch divided by tooth area of tooth. We are not considering the area of slot. Then the real flux density is defined as the actual flux in a slot pitch. Actual flux in a slot pitch divided by tooth area. Now let's derive a relation between real and apparent flux densities. First let's consider the net iron area over one slot pitch. This is one slot pitch. Here the net iron area means width of tooth into length of tooth. Length of tooth is equal to length of core of the machine. But here we have to consider the net iron area. That means we have to consider the net iron length of core into width of tooth. And area of air path is equal to total area minus iron area. Area of air path means the path of flux through air. Area of air path, AA, is equal to total area under slot pitch minus iron area under slot pitch. That is equal to total length of core of the machine into slot pitch. This is a slot pitch into total length of core length of the machine minus net iron length of the machine into width of teeth. That is AI. Now the total flux over one slot pitch, that is phi S, is equal to flux through iron path plus flux through air path. And by definition, the apparent flux density is given by the total flux over one slot pitch divided by the tooth area, that is the area of iron path. that is equal to phi I plus phi A divided by AI, that is equal to phi I by AI plus phi A by AI. Let's modify this equation by multiplying the second term, the numerator and denominator of the second term, by AA. So the equation becomes phi I by AI plus phi A by AI into AA by AA. And let's group this terms, that is phi A by AA and AA by AI. We are going to regroup this. Then the equation becomes B apparent is equal to phi A by AI plus phi A by AA into AA by AA. This phi A by AA means the flux through the air divided by area of cross section of air path. That means the flux density in air, phi by A, the flux density in air into AA by AI. Now let's define a term K, which is equal to AA by AI, and here we have substituted the values of AA and AI. This equation we have already written, that is AA is equal to LYS minus LIWT divided by LIWT, that is equal to YSL divided by WTLI minus 1. This term is again represented by another notation, that is KS minus 1. So small letter k is equal to KS minus 1. Now again let's rewrite this equation for apparent flux density, that is B apparent is equal to phi I by AI, it is equal to the real flux density plus, by definition, real flux density is equal to phi I by AI plus B air, that is, as we have already said, the flux density in air into AA by AI is small letter k. Or we can write apparent flux density is equal to real flux density plus, instead of k we can write Ks minus 1 into B air. Or we can write B real plus Ks minus 1 into, instead of B air we can write mu 0 H. Thank you.